everyone, this is Nikki Jackson, one of the adjunct instructors for Concord Career College. Right now you should see an example stating for question 1 details. This is pertaining to Module 4 homework, and all of Module 4 is dealing with matrices and systems of equations. So the reason why it's considered a system of equations, notice how you have more than one equation. You also have more than one variable. So in this case, the variables are x and y. You also see that the answer choice is written as a solution set, meaning that it has the parentheses and it has the comma. So x comes first and then you have your y. So for this particular example, we have 8 over 4, or 8 and 4. So let me show you how we did that. Also, feel free to pause, rewind, fast forward if you're already comfortable with everything that we're doing. Please note that sometimes there may be a break in the videos, hence there are going to be multiple parts, so thank you for your patience and your understanding. So let me zoom in slowly. As previously stated, Module 4 is focused on matrices, so not like the movie, The Matrix. These matrices are dealing with the equations. So let me zoom in slightly. Hopefully the reflection is not too bad with the camera on here. So here we go. So question 1, we have 2 equations. We have x minus y equals 4. Then the second equation is 2x plus y equals 20. One way to solve for x and y is substitution. So here's what I mean by substitution. I like to keep stuff positive. So for the second equation, I'm going to rewrite it where I only have what y is. So I'm isolating the variable of y. So when I rewrote it, I have 2x plus y equals 20. I subtracted the 2x from both sides. So now I'm left with y equals negative 2x plus 20. Now what we're going to do with this equation is substitute it into the first equation, which is this one right here. So notice how I substituted in. So we have the new one. And you see how it says y. So in the first one, we're going to see whatever we just solved for and substitute it in for y. So right here, once we substitute, this negative is going to change everything on the inside of the parentheses. So now we have a positive 2x minus 20 equals 4. Moving on, we're going to combine our like terms. So right here we have 1x plus 2x, which gives you a 3x. This is like an invisible 1 right here. So now we have 3x minus 20 equals 4. Combine your like terms. So we're combining the numbers that do not have letters or variables. Notice how the 4 is already isolated, so that's the reason why we're plusing the 20 on both sides. So now we got 3x equals 24. To isolate the variable of x, divide both sides by 3, and we got our x right here. But wait, there's more. We also have to go back and solve for y. So going back to that very first equation where we had x minus y equals 4. Well, now I know what x is, so I'm going to substitute my x in as 8. So 8 minus y equals 4. We're combining our like terms now, so we're going to subtract 8 from both sides. So bring down the minus y. 4 minus 8 gives you negative 4. Divide both sides by negative 1. Now notice how I didn't write that step out, because it's the same thing as saying that 2 negatives make a positive. So that's just a side note right there. We divided both sides by negative 1. We know that 2 negatives give you a positive. So your final answer is 4 for y. Rewriting it as an ordered pair, the solution, aka the answer, is going to be 8 over 4. So that's what we solved for the first term. Your next one is still dealing with the system of equations. So once again, please allow me to zoom in and out. So this one looks quite similar in regards to the answers, but they are two totally different equations. So I have to emphasize that. So this time around, you may notice that we have more of the coefficients. That means those are the numbers that go with it. So I'm going to show you a different way of doing this using the calculator. Now for time purposes, if you want to do it manually, please feel free to watch the other Cengage videos that are posted in Canvas for this course. But right now I'm going to show you how to use the calculator way. So you may recall during the first day of class, I requested that you download the TI-83 or TI-84 calculator. If not, please reach out to me or one of your peers so you know exactly how to download it. So one of the things that I did, I rewrote it. So here's your equation right here, or system of equations. Notice when I rewrote it, I only used my coefficients. Now the coefficients are the same thing as your numbers. So I rewrote the 5, -1. Remember, you're looking at 1y. Then the -44. Then the +2, +3, -4. So this is what I got. Now this is one of the ideal things that you might want to stop and pause this video periodically. And the reason being, there are a lot of steps to using the calculator. But overall, especially when it's time for you to take an exam, this will really help. The steps are going to be very similar to when you use your phone. Just be careful if you're using the digital version on your phone. Make sure you read them because they are set up a little bit differently because the screen is a lot smaller. So once I cut it on, I'm going to hit clear just in case I've used it before. So let me zoom in slightly so you can actually see what I'm doing. So hopefully you can see the green fingernail polish screen. Let's go. So once I cut it on, I'm going to hit second, then matrix. Now matrix is directly below the math key. Once you have hit that, use your right arrow key. So let me move it slightly to the right so y'all can see everything. So I'm moving it to the right to go to edit. Hit enter. Now the reason why I'm saying select matrix A because that's the very first one. So once you select matrix A, that automatically hits enter for edit. We now are going to enter 2, enter, and 3. Now the reason why we're doing 2 and 3, you see 2 rows right here, and you see 3 columns. So it's a 2 by 3. So make sure you hit enter for this part here. Now we're going to input the numbers as we see them. Make sure you hit enter each time you do it. So we got 5, -1, -44, 2, 3, and -4. Once we have completed that step, hit your second key, then mode. Hit your second key and matrix again. So that's the 4th key under your second key. Use your right arrow key. Go to math. Go all the way down using your down arrow key until you see RREF. Make sure it has 2 R's. That represents reduced row echelon form. Hit enter. Hit your second key. Go down to matrix again. Notice how it's like the subscript, the smaller print. We use matrix A, so make sure you select matrix A. Hit enter. Enter again. Looking at the column, the very last column right here, you know that your answer now is x equals -8 and y is +4. So once again, feel free to actually rewind and look at these steps because I'm going to do it constantly and it's a little bit easier to use a calculator once you get comfortable using it multiple times. The other reason why I'm doing that is because it's a little bit easier to do this using your calculator. With that being said, here's yet another system of equations. As stated earlier, if you want to do it manually, I encourage you to do so. It's always a good way to know how to do stuff more than once or more than one way. Because that's just how math is. So you already know what your answer is. It's 5 and 0. Once again, I'm going to use my calculator. By the way, you could also use the substitution formula for this one right here because it's telling you what y already is. But if you're more comfortable because of your exams are timed, to show you how to use the calculator. So one of the things that I did is to zoom out so you can see it. Yeah, that might be helpful. Okay, so let me get this out the way. So thank you for your patience. So given to you, you had 2 equations. Y equals 4x minus 20 And then you had it in standard form, 7x plus y equals 35. Again, two different equations. I'm going to rewrite the first equation to make it look like the second equation, which is in standard form. So I want my x and my y to be on the same side of the equal sign. So once I rewrite it, I'm going to subtract 4 from both sides, giving me negative 4x plus y equals negative 20. Once both of them are in standard form, so I'm going to inch that up just a little bit, I'm going to rewrite it in a matrix. So now, using my numbers only, I have negative 4, 1, and negative 20 for my first equation. Then for my second equation, I have 7, 1, and 35. So I'm going to split this up a little bit. So now you can see how I'm going to use the calculator again. So my old matrix is still down there. So I'm going to hit clear. It's a glare right there. So there we go. So I'm going to hit second matrix. Use my right arrow key. Go over to edit. Hit enter for selecting matrix A. Now matrix A is always the easier one to do because A comes first in the alphabet. Hence that's going to be your first choice by default in the calculator. This one is still a 2 by 3 because you have 2 rows and 3 columns. So hit 2 enter and 3 enter. If you're using the touch screen, just be careful on how you touch it on your calculator. Now for your coefficients, let me zoom in a slight bit. I'm going to type in the numbers that I see. So negative 4, enter, 1, enter, negative 20, enter, 7, enter, 1, enter, and 35, enter. So I got my numbers in. Now hit your second in mode key. Second matrix again. Use your right arrow key. Go to math. Go all the way down until you see RREF. Make sure it has 2 R's. Hit enter. Second matrix once again. We're going to hit enter for matrix A. Enter again. And notice how we have our solution set. So we're looking at this last column right here. So we know that x is going to be 5 and y is going to be 0. So hopefully once we keep doing this over and over, you feel a little bit more comfortable in using the calculator because it serves a little bit extra time than we use on other assignments. So hopefully so far so good. At least I hope so. And you hear paper wrangling, so my apologies. So now we're going on to the next one. That is dealing with number 4. So you hear all of the paper rambling, so my apologies for that. So here we go. So let me zoom in for you. Oops, I probably zoomed in a little bit too much on that one, because this is a reading problem. So give me a moment to do this so you can all see it. Ooh, that's too small, so I'm sorry, y'all. So let me read it out loud as best as I can and then show you how to do it manually. A motel rents double rooms at $32 per day and single rooms at $27 per day. If 25 rooms were rented one day for a total of $765, how many rooms of each kind were rented? So once again, this is the ideal time for us to actually pause and rewind it. So let me zoom out so you can see what I'm doing. So your problem is going to be slightly different because it's going to change the numbers in your word problem. Since we're doing the system of equations, we're going to use the variables of x and y. We're going to let x represent the double rooms and let y represent the single rooms. When I read the problem, they had a total of $765. So I'm having it equal a total of money. Then we also knew that each room we had a certain charge. So there were $32 for a double and $27 for a single. So notice how the money is in all one equation. Also in the problem for your second equation, it was dealing with the number of rooms. So you had a total of 25 rooms that were rented that day, meaning that you had X for your double rooms and Y for your singles. So if you can see the different colors, and I sincerely hope you can, this part right here, you're going to rewrite as a matrix. Now, if you do this manually, I suggest that you use substitution using the second equation. But for time purposes, we're going to use the calculator. So here we are. Let me adjust this so everybody can see it. So I'm going to hit second matrix. Use your right arrow key to edit. Hit enter. We know that it is a 2 by 3 because we have 2 rows and 3 columns. So 2 enter, 3 enter. Now we're going to input our numbers. 32, 27, 765, then 1, 1, and 25. Second quit. Second matrix. Use your right arrow key, go to math. And hopefully you remember that we're going to be using RREF. Notice how the steps are repeating themselves. So hit enter. Second matrix, enter, because you did option 1 or matrix A. And look at the last column. So that's what I mean by there. So here's where the reading comes in handy. We have to know what the single and the double were. So we had X as your double and we had Y as the single. So make sure you read that carefully. Read it carefully. So that means that we had 7 double rooms. And we had 18 singles. Now, yes, I did write this differently. And the reason why I did that, when it's your turn to do it, we got to read carefully. So going back to the calculator, we know X comes first and then Y. But in regards to the actual computer example for it, make sure you read it so you know exactly what you're doing. Your next one is yet another reading problem. So give me a moment to actually find it, because I have all my papers scattered everywhere. And I did that on purpose. Yes, I did. Alright. So now that I got myself somewhat organized, your problem is going to be very similar to this. So I can't zoom in too much because then you won't be able to see it. So once again, I'm going to have to read it. Sam invested $1,800. Part of it was 6% and the rest of it at 8% yearly interest. The yearly income of the 8% investment was $24 more than twice the income of the 6% investment. How much did he invest at each rate? So let's take a moment to breathe. Woosa. Ooh. So don't get too anxious about this. Just make sure you read it carefully. So when you rewrite this, you know that your money is going to be a part of something, and then you have another equation. So let me show you what I did. First, we had to find out what the equation was. So we're pertaining to our total. So I said earlier, Sam invested $1,800. So that's my first equation. So one of these represents your 6%, the other one represents your 8%. The next, it says the yearly income on the 8% investment was $24 more. So there goes the $24 more. Then twice, there's the twice. Then the income from the 6% income. So does it make sense? Hopefully it does. So on side note, we're going to say X is your 6%. Y was your 8%. Now your numbers are going to be different when it's your turn to do it in regards to the amount, but your percentages still should be the same. So what I'm going to do, I'm going to rewrite this equation right here in standard form. So my x's and my y's are on the same side of the equal sign. So one of the things that I did was double it because it said twice. So I multiplied 2 times 0.06x. So that's just what I got. Then I subtracted from both sides. So now, once it's rewritten in the standard form, I can write it as my matrix. So let me zoom out so you can see what I did. So for your first equation, my coefficients are 1, 1, and 1800. That comes from this equation. Then for my second equation, that comes from this one, I got negative 0.12, positive 0.08, and then positive 24. You may have also noticed that I changed my percentages that were given to me in the problem to decimal. So that was move that imaginary decimal 2 places to the left. So now that I have this, guess what we're going to use now, y'all? That calculator. Now feel free to stop, pause, and do similar examples for your homework when it's your turn to try this. Because of time, I can't keep you really engaged in it, but try your best and feel free to email me or use the Remind app if you got any questions. So second matrix, go over to edit. We're going to hit enter for matrix 1. It is also still a 2 by 3 because you have 2 rows and 3 columns. So notice how I'm hitting enter each time I put a number in. So you should have gotten into the habit of typing quite quickly. At least I hope you have. So there we go with our new matrix. So second, quit. We have to exit out the app to go back in. Second matrix, go over to your map key. Go down to RREF. Second matrix, hit enter for A. Hit enter again. And look, we have our answer. So for the 6%, that's going to be $600. And then for the 8%, that was going to be the $1,200. Because remember, X comes before Y. Woohoo! So hopefully we're feeling pretty good with our calculator, y'all. Feeling good with your calculator, y'all. So now we're going on to another example. Again, I'm just shuffling all these papers, so my apologies for all the sound bites that we might have. But I'm sure we can do it. My imitation of the water boy. Okay, awesome. So I found in my mixture of papers what we're supposed to be doing. So let me zoom in if I can. Alright, there we go. So I had to write notes to myself like help, meaning that I have to use my calculator for the additional parts. So just ignore that. But for this one, this is also another one that has help on it. We're going to rewrite it matrix style. So pay close attention to where I'm getting the numbers from. So you may see for that first row, I have 1, negative 2, 3, and 19. Second row is 2, 1, 5, 39. Third row is 3, negative 4, negative 2, and 15. We already know that our answer for X, Y, and Z is going to be 9, 1, and 14. So here's another reason why I'm choosing to use the calculator, because instead of using 2 variables now we have 3. So it might be a little bit easier to use a calculator. So as I just said what the coefficients were, now you see why I'm writing out the coefficients. So let me zoom out so you can actually see. So there we go. This time around, this one is going to be a 3 by 4 matrix because you have 1, 2, 3 rows and 1, 2, 3, 4 columns. So this is going to be a 3 by 4. We're still using our calculators. So let me bring it in just a little bit. So second matrix, Go over to Edit, hit Enter, choose Option for Matrix A. This time we know it's going to be a 3 by 4. So hit 3 Enter, then 4 Enter. Now we're going to put our numbers in. 1, -2, 3, 19 for the first row. The second row is 2, 1, 5, and 39 for the second one. And your third row is 3, -4, -2, and +15. Once you enter second mode, because that's the same thing as exiting or quitting the app. Second matrix, use your right arrow key, go to Map, go all the way down until you see RREF or Reduced Row Echelon Form. Hit Enter. Second matrix again, hit Matrix A, so just hit Enter. Hit Enter again. And boom, bam, pow, we got those same answers. So looking at that last column, X is 9, Y is 1, and Z is 4. So yay, we're doing it, y'all. So you notice that was number 6. So let's look at number 7. I'm going to have to read number 7 for you, so we can have a better understanding of what's really going on. And unfortunately, I don't have a screen where y'all can see everything, which is rather disappointing. Especially if I zoom in, it's going to cut off some of the words. That's not good. Okay, so that's about as clear as it's going to get without me cutting it off, so my apologies. So let me read it out. It says a box contains $8 in nickels, dimes, and quarters. There are 47 coins in all, and the sum of the number of nickels and dimes is 3 less than the number of quarters. How many coins of each kind are there? So let me repeat it. A box contains $8 in nickels, dimes, and quarters. There are 47 coins in all, and the sum of the numbers of nickels, dimes, is 3 less than the number of quarters. How many coins of each are there? So we know that this is also going to be another 3 by 4 matrix. So notice the emphasis on the nickels, dimes, and quarters. So we know that a nickel is worth 5 cents, a dime is worth 10 cents, and a quarter is worth 25 cents. The problem itself said that it was worth $8. So when I write it out, that's going to be my first equation right here. So 0.05x, that's my nickels. The 0.10y, those are my dimes. And then the 0.25z are my quarters, which give me a total of $8. Also in the problem, it says there's a total of 47 coins. My bad. So we had x plus y plus z, which is 47. Your third equation is where it stated that the sum of your dimes and nickels was 3 less than your quarters. Hence your third one. So notice how the first 2 equations are already in standard form, meaning that you have your x, your y, and your z's, and your constants. They're already there. But this one right here, we're going to have to rewrite. Now the reason why we have to rewrite it, we want the x, y, and z's to be on the same side of the equal sign. So that's what I did right here. I subtracted z from both sides of the equal sign. So now I have x, y, and minus z equals -3. So once I rewrite all of that using the matrix, we know that it's going to be a 3 by 4. So for your first equation, you have 0.06, 0.10, 0.25, and your constant is 8. The second row is 1, 1, 1, and 47, because I'm going by this right here. Then your last row, using this, you got 1, 1, -1, -3. Using your calculator, second matrix, go over to Edit, hit Enter. Since it's already a 3 by 4, so enter, enter. Now we're going to enter the first row. Be careful with your decimals. Now we're going to hit the second row and your third row. Now if I'm going a little bit too fast, please feel free to pause. Now I'm going to exit, so second mode. Go back to calculate, so second matrix, use your right arrow key, go to math, go all the way down till you see RREF, so hit enter. Second matrix, select matrix A. Looking at your last row. So over here on the side, this glare is there. So I'm going to have 9 nickels for this particular example, 13 dimes, and then I'm going to have 25 quarters. Once again, if you want to do this manually, feel free to do so. Just make sure that you have enough time to go back and do it. Alright, going on to our next example, which should be number 8. So let me find all my papers again. So while I'm going through my disarray of stuff, again, my apologies. This is a good time to make sure that you're writing everything down. You may have noticed now that we're doing a lot of the stuff using the calculators, which is what should be expected, especially with 8 and 9. So let me zoom in. So 8 and 9 are asking you to find the reduced echelon form. Well, that should be kind of simple because we've done this already. You may have noticed in the previous examples when we were doing stuff like this, especially for this one, this is a 3 by 4 because you got 3 rows and 4 columns. So I know all my numbers in that first row should be 1, 0, 0, and whatever my value of x is. For that second row, there should be 0, 1, 0, and whatever my value for my y is. And for the third row, 0, 0, 1, and whatever your z is. Now I'm getting that because it's a 3 by 4. You may have noticed when we were doing this in the other ones that there was a diagonal of 1s. Then you had your solution set for the last column. And everything else was zeros. Well, if we're looking at this carefully, I have a diagonal of 1s, but everything else is not 0, so this is why this is a no. I'm going to zoom out and go to number 9. Number 9 is asking for the exact same thing. Now this time around, it looks like it's a 4 by 5 because we have 1, 2, 3, 4 rows and 1, 2, 3, 4, 5 columns. So let's rewrite it using reduced row echelon. So I'm going to have 1, 1, 2, 3, 4. Then that's going to be my x. Then a 0, then a 1, then a 0, 0, then my y. Then I'm going to have a 0, 0, 1, 0, whatever my z was. Then I'm going to have a 0, 0, 0, 1, and whatever your next variable is going to be. I'm just going to say for a for right now. And you can't see that while I'm writing. So once again, notice how you have a diagonal of 1s. So right here, it looks like they messed up on this column right here, right there. So this is also a no. So ladies, gents, individuals, reduced echelon form. So let me zoom back out for number 8 as well. You will always have a diagonal of 1s. That's how you'll know if it's reduced row echelon. Even if there's a diagonal, be mindful that everything else has to be zeros. So that's going to be the catch. Notice how we also went beyond the x, y, and z. We stop. We had to start all over again. Well, that's fine. You can have as large as matrices as you want to. Hence why we're using the calculator. So let's look at this one. Pay close attention to your numbers. Now, the reason why I'm emphasizing that, this is a large one. In fact, what is this? This is a 1, 2, 3. This is also a 4 by 5. So this is a 4 by 5 matrix. This will be the ideal time for you to pause and actually write the numbers down, because this is where these numbers are coming from. Those are all your whole numbers. And of course, you already know that I'm going to be using the matrix for this. So second matrix, go over to edit. This is not going to be a 4 by 5. I might help if you actually see it, huh? Alright, there we go. So let's put our numbers in. 1, -3, -2, 1, -3, -2, 7, 1, -2, -1, 3, 7, -3, 3, -5, 5, 1, 4, -2, 18. Woo, that was a lot. Second matrix. Go over the mouth, go all the way down to RREFs for reduced row echelon form. So that's going back to 8 and 9 examples. Remember, you're looking for your diagonals of 1s and 0s. Hit enter. We're going back to second matrix. We're going to select matrix A. Hit enter twice. Now that looks kind of different, doesn't it? And it's supposed to be. Because I did something wrong. What did I do wrong, y'all? Let's go back and see. So 1, -3. It's telling me what I did wrong. -3. I had to make this stuff. 3, -2, -3, -2, 7, 1, -2, 1, 3, 7, -3, 3, -5, 5, 1, 4, -2, 18. So my apologies for the time delay. I didn't get what I was supposed to get when I wrote it down earlier. And I still got the same thing. So I did something wrong, but I'm looking at the time that I have, and I don't want this video to stop. So my apologies. I'm human. I make mistakes. I'm probably going to make some more, but we did enter that right. So I'm not really sure what to tell you other than do not make the same mistake that I did. But I inputted something wrong, and I'm not sure what it was. So my apologies. Let's look at number 11 now. But that's interesting. I want to know what I did. So you hear the rustle and bustle of paper again. Let's look at number 11 and 12 and 13. They're still pertaining to matrices. So this particular problem is already solved for you in reduced row echelon form. It's asking you to find out what x1, x2, x3, and x4 are, which is already given. So x1 is -1 because you see it given to you. x2 is +3. Again, you're looking at it right here. x3 equals -1, and then x4 equals 0. So yay! We figured that one out. So again, my apologies for number 10. 12 is asking you to find the determinant. So we're going back to the calculator. I'm going to go to second matrix, go over to edit. This one is a 2 by 2 matrix. So we're going to put in 3, 3, 8, -2. Second mode, and again, it might help if you actually saw it. I didn't realize it was cutting it off, ladies, gents, individuals. So again, my apologies. Second matrix, go over to math using your right arrow key. Now this time we're looking for determinant. So that's what the DET stands for. So that's your first option. So hit enter. Second matrix again. We use matrix A, so hit enter twice. Voila! We actually got the same answer. So that's what we have right here. Let's do the same thing for number 13. So 13, what type of matrix do you think that is? So we have 1, 2, 3, 3 rows and 3 columns. So this is a 3 by 3. We already know that the answer is going to be 68. So let's figure out how to put that in. We're trying to find the determinant. So second math, go over to edit to input the numbers in. So we're going to hit enter for matrix A. So 3 by 3. So now we have 1, 2, negative 3, negative 3, negative 1, 1, 5, 6, and 5. Once we put them in, second mode, second matrix, use your right arrow key. We're looking for the determinant because we realized that when we read the instructions. Hit enter, second matrix again, enter, enter. Yes! We got it, we got it, we got it, got it. So yay for us. Moving on to more matrices. Yes, so exciting. I'm so excited. And I just can't hide it. Actually, I can't hide it because you can't see my face. And I'm looking for number 14. Alright. So 14 and 15. Here we go. Let me zoom in so we can see that a little bit more clearly. So we know that this is a 2 by 3 matrix. We also know that our answer is going to be 1, 7. So let's figure out how we're going to put this in our calculator. So I'm going to go to second matrix, once you can see it. Go over to edit, hit enter. This is a 2 by 3 matrix. So for your first row, you have 2, negative 1, negative 5. Second row, we have 3, 2, and 17. So I'm getting it from the numbers. Second mode to exit out of the app. Second matrix again. Go over to math. Go all the way down until you see RREF. So hit enter. Second matrix. Enter again. Enter one more time. Voila! Our last column matches what the answer choices are. Let's do the same thing for number 15. So again, feel free to stop, rewind, or fast forward throughout the course of this video. Also be mindful that there are other videos provided for you through Cengage that's in Canvas. So for this one, it looks like it is a 3 by 4 matrix because you have 3 rows and 4 columns. We also know that our answers are going to be in fractions. So we definitely need to pay attention to this part here. So let me zoom out just a tad bit. So second matrix, go over to edit, hit enter. We're going to keep using matrix A, so now it's a 3 by 4, so hit enter for that. Your numbers are 3, negative 2, negative 3, negative 9. Second row, 1, 2, 3, negative 3. Third row, negative 1, 4, negative 6, and 7. So hopefully you can see where I'm getting these numbers from right here. Now second matrix, let me zoom in just a tad bit, make it a little bit easier. Second matrix, open the mouth, go all the way down until you see RREF. Second matrix again, select matrix A, hit enter twice. Well, we got decimals, so let me show you what to do. Hopefully you can see my green fingernail polish, green means go. We're going to hit the math key. We want fractions. Hit enter, because that's the first thing you see is fraction. Hit enter again. Look at that. Look what happened, y'all. So it gave you the fractions. Now why mine are not simplified, I'm really not sure. But there's the wonderful world of technology. We try to make it more convenient, but sometimes it's just not that way. And I believe I made a mistake with one of my numbers. And we learned from the first time when I made a mistake. Mistakes going to happen. We just need to learn from it. So let me see if I learned from my first mistake. And I should have. At least I'm really hoping that I did. And I believe I did.
I did.
I did, y'all.
So I'm going to hit my math key, fraction, hit enter twice.
Yeah, buddy. Look at them mountains. Look at them mountains. They the same thing now. So I learned from my mistake.
So awesome sauce. That is great. That is beautiful.
I am proud of myself.
Hopefully you guys have learned how to use the calculator as well.
But wait, there's more. Now that we've done matrices, let's figure out how to do a system of equations in regards to graphing. Here we go. So here goes the graph. Let me zoom in slightly so you can actually see the two equations. So much fun. Yay. So here's where it gets a little complicated. You have to navigate how to use the graphing tool using Cengage. So this is going to be like a trial and error thing. But I'm going to try to show you how to do it more than one way. So please forgive me. Now this is going back to what we learned from Module 2 in regards to our inequalities. So hopefully at one point in time you actually wrote all of those down. So in case you didn't, I will show you how to do it. But let's figure out how to do this one first. Alright, so this is an inequality. In regards to Module 2, we have to know whether we're going to shade left or shade right. Well, this is going to be a little bit more complicated because now instead of using equations, we're using inequalities. So if it is less than, we know we're going to have a dashed line when we connect our dots because remember we're graphing. And we also know that we're going to shade under because it's less than. Not only do we have a less than, we also have a less than and equal to. Now because it has an equal to, you have to include whatever is going to be less than. So that makes it a solid line when we connect the dots. But we're still going to shade under. Because think about what an inequality means. It just means that something is less than. And it has to include infinity. Because, for example, negative 42 is less than 1. But so is negative 93, so is negative 1,246. So, you have to be careful with that. Next, we have our greater than. This is also a dashed line when you connect your dots. Because it's greater, though, you're going to shade over. And then you have your greater than or equal to. This is going to be a solid line because it has to include whatever it's greater than. And you're still going to shade over. So this is the ideal time to pause and to write that down. Because this is going to be something that I'm going to be referring to throughout the next several examples. Now, so let's go back to the actual problem. Here's your equation for inequalities in the form of a system of equations. Boom, bam, pow. There are two of them. So here we go. Let me zoom out. So here goes the two. Well, one of the things that we want to do is find the x and y intercepts for each one of these inequalities so we can make it easier to graph. So let me inch it on up so you can see what I did. So for the first set, I let my x equal 0. So I substituted 0 for each one of these. So for the first one, I have 0 and 7. And then for the second one, I have 0 and negative 3. Now pay close attention to this one right here. When I substituted my 0 in, that left me with a negative y greater than 3. Now you may remember from Module 2, whenever we had a negative variable, we had to flip our sign. In regards to the sign, I'm looking at y because that's dealing with slope-intercept form. This one is going to be a dash, and I'm going to shade over. This one also going to be a dash, and I'm going to shade under. Don't forget, I flipped right here. But that's just with your x-intercepts. Now we have to move on to our y-intercepts. So for the y-intercepts, you let y equal 0 for both. So for this one, I have 7 and 0. And then for this one, I didn't have to flip anything, but I have 3 and 0. Now we're going to graph it. So your coordinates are 0 and 7, 7 and 0, 0, negative 3, and 3 and 0. Now they're not going to always be the same numbers like that, but they're going to be a little bit easier to graph. So let's do the first one. We got 0, 7 for 1 point. And then we have, let me use that, because that's going to look like a 10. Then we have 7 and 0. Then for your next point, or connect the dots, we got 0, negative 3, and we got 3 and 0 today. So let's make those points now. So starting at the origin, which is 0, go up 7 times, apply to my first point. Because x comes first, I went back to the 0 and went over 7 times, applied at my second point. Connected the dots with a dashed line. Next equation, or inequality. Go to 0, go down 3 times because this is 0, you're negative. Plot your point. Go back to 0, go to your right 3 times, plot your point. Connect the dots using a dash line. Dash a dot, they're the same in my mind right now. Now remember earlier, one of them was greater than, so we're going to have to shade over this line, but yet under this line because we have to flip it. So this is going to be your shading mark. There should be like a paintbrush or either a highlighter on your screen when it's your turn to do this. So you might have to practice a few times just to get the hang of it. But we have even more graphs. Check this one out. So let me zoom in. So for this one, we don't necessarily have to connect the dots with anything, but we do have to be mindful of how we're shading. So for both of these, we know that we're going to have solid lines, and we also know that we're going to shade under. So for these, I'm looking for a 3 on the x-axis. So here goes my 3 on the x-axis. It's going to be a vertical line. And the reason why it's a solid line is because it's less than or equal to. Then for the next one, I'm looking for negative 5 on the y-axis. So here we go. That's going to be a horizontal line. But since both of them are going to be less than, we have to shade to the left or under that. So hence, this is where your shading is. Now, the reason why I'm saying to the left of this line, think about what we did on the number line in Module 2. If it was a less than or less than equal to, we shaded left. If it was a greater than or a greater than 2, we shaded right. So, those are just your inequalities. So here's going to be our last example. When you submit homework 4, send me an email so I can make corrections to 19 and 20. I'm not going to be able to do that because of time restraints right now. So my apologies. But again, you do have other videos and other resources available to you. Let me zoom in for this one so we can have a better understanding of what we're doing. So given to you, you have a function for x and y. But within that function is the equation of 7x plus 8y. They want to know what would be the maximum and minimum value of this given function. So again, the function is the same thing as your equation. So 7x plus 8y. But if you look carefully at this picture, they look like they're giving you some vertices. So the vertices are a fancy way of saying corners. So you got a 4-sided shape. It's kind of slanted right here. I don't know if you can see it or not. But we're going to use these corners, aka vertices, and substitute their forms in. So let me show you what I'm going to do. So you got 1, 2, 3 different points. So if I were you, I'll jot these down real quick so you can see where I'm getting the numbers from. And I also will rewrite the function itself. So here's what I did. and hopefully you can see it. So let me try to zoom out a little more. Okay, so I followed my own instructions, the same ones I gave you. I jotted down those vertices. So here goes 1 and 1, 5 and 2, 2 and 4, and 4 and 8. But here's what I didn't tell you. These are also my x values and my y values. Notice what I did. I substitute them into this particular function, aka equation. So for the first one, I got 1 and 1. So 7 times 1 is 7, 8 times 1 is 8, 7 plus 8 is 15. Second equation. Substitute x is 5, y is 2, so 7 times 5 is 32. 8 times 2 is 16, so 35 plus 16 gave you 51. Next point, we substituted x as 2, y as 4, so 7 times 2 is 14, 18 times 4 is 32. So add those two together, you got 46. Then your last one, we substituted x as 4, and then y as 8. So 7 times 4 is 28, 8 times 8 is 64, 28 plus 64 gave you 92. So looking at all four of these numbers after the substitution, we see that 15 was the smallest one, and 92 was the largest. Did you get your maximum and minimum? So ladies, gents, individuals, thank you for watching this video and being oh so patient when I was going back and forth with all my paperwork. Those of you who are actually enrolled in a Math 1320 class for this particular school, let me know about 19 and 20. But if you're in my class, I already got you. But other than that, I appreciate you watching.